Okay, now let's continue our finishing our example in the previous episode, which is just the end of this example when we are trying to solve this linear programming problem by drawing little pictures for this linear program problem. Okay, so recall that we were discussing the slope of this uh, constraint here. Okay, so which has a negative slope of the negative 1 over the 1 minus epsilon. So actually we're comparing this number to the minus 1. And the reason is that because in our objective function, we have this minus slope of minus 1, right? Okay, so here initially we have this plot, and the blue the black line here, this one is simply the first constraint. That doesn't matter here, we already know that. So the blue line here, it is the constraint that is derived, which is drawn from this inequality. Okay, so actually that has a downward slope of this 1 over 1 minus epsilon, and we're trying to discuss the value of this epsilon here. Okay, so specifically, if epsilon has a positive value, this means that minus 1 over 1 minus epsilon, this is less than uh, minus 1. So it means that this line is steeper. Okay, so it is steeper than a line with negative 1 slope. So here our objective function, although it doesn't look like it has a minus 1 slope, but we just suppose that it has that. Okay, so let's say that this object function has a downward slope of minus 1, and so this angle is 45 degrees. So here, the blue line, it is steeper than the red line here. Okay, so essentially it means that our feasible domain or the feasible set is actually this space here. Okay, so we can see that if our objective function, since it has a downward slope of minus 1, then actually the optimal point should be the intersection here, right? So it should be here on the vertical axis. Okay, and then the result, the numbers doesn't matter, we just need to know the intuition here. Okay, so what if the epsilon is a negative number, as we mentioned in the beginning? So it could be positive or negative. So if it is a negative number, then in this case, 1 minus 1 over 1 minus epsilon, this is greater than minus 1. So it means that this blue line, it is flatter. Okay, so here again we have our objective function, which has a minus 1 downward slope for this line, and this blue line, it is flatter here. Okay, flatter than the objective function. So of course, the intersection of those two lines here at the optimum for the object function, it should be somewhere here. Okay, so it has to be the actually it cannot be the point on the vertical axis, right? So it has to be somewhere here. Okay, so that's the difference between the difference led from the different values of the epsilon, and by intuitively the different values of the epsilon, it means the different effects, either substitution or the complementary effects for the two investors, right, together. So, and that essentially now it leads to different results for this linear programming problem. Okay. All right. So, as a conclusion to this example and the information design problem using the linear programming approach, so we can observe that when the action and the state is finite, so if they're finite sets, then we can use the linear programming approach for to solve the information design problem, and this is pretty easy, and it's much easier than the more convenient than what we did in the concavification and in that approach, right? So, okay, that's it.